Ayo, mic check, 1, 2. Okay, so now this is the next question. They basically told us to solve this using the Lagrangian method of multipliers. Whenever we get any question, we just need to check firstly how many variables are there. As you can see, there are only two variables used, x1, x2, x1, x2, x2 and x2. And number of constraints also is important. We have two constraints. So in this question, we have two constraints and two constraints, and two variables. Okay, so now firstly we start by just assuming everything. Like let f of x1 x2, since two variables x1 and x2 equal to the function this thing z basically. Yeah, okay, this is a function, be the function to be optimized. Okay, cool. Then we can look at our constraints. So now we have two constraints, so we can take them as h1 and h2. Also remember, always we take this whatever constant is there on the right, we take it to the left. So let h1 is equal to 4x1 plus 5x2 minus 13, and let h2 is equal to 3x1 plus 4x2 minus 10. Right, so we got our two constraints here. Since we have two constraints, now when we are defining a Lagrangian function, we shall have two Lagrangian multipliers, lambda 1 and lambda 2, that is. So we'll have f of x1, f of x2, lambda 1, lambda 2, which is equal to, this is a Lagrangian function, no? So capital L is equal to f of x1, x2, our function, minus lambda 1 h1 minus lambda 2 h2. Now we just substitute this. This is like the boring part, okay? But yeah, you still have to do it. Yeah, so now lambda 1 h1 minus lambda 2 h2. Nice. Now since we basically whenever we need to calculate anything, or rather after this step, we need to calculate four things. We need to calculate the partial derivatives of a Lagrangian function with respect to x1, x2, lambda 1, lambda 2. Basically all the variables used here, we need to differentiate it with at least one, and then put them equal to 0. So basically we need to calculate uska differentiation with respect to x1, put it equal to 0. Same for x2, put it equal to 0. Same for lambda 1, put it equal to 0, and same for lambda 2. Nice. Okay, so now let's start calculating. So we get this is just normal differentiation. Okay, we get 5 minus 2 x1 minus 4 lambda 1 equal to 0. Okay, then for the next one, with respect to x2, we get 9 minus 2x2 minus 5 lambda 2 is equal to 0. Oh shit, I forgot. I differentiated with respect to this. I forgot about this. Minus 3 lambda 2 is equal to 0. And for this one, minus 5 lambda 1 and minus 4 lambda 2 equal to 0. Now we differentiate it with respect to lambda 1. So now we basically just get the constraint, okay? 5x2 minus 13 equal to 0. Same for lambda 2. 3x1 plus 4x2 minus 10 equal to 0. So now we basically differentiated 4 times, right? With 4 different variables, so multiplies, whatever. So now we got 4 equations. Now if you just pop them into the calci and solve them, we should basically get the values of x1, x2, y1, y2. Lambda 1, lambda 2. Yeah. Simultaneous equations, 4 unknowns because x1, x2, lambda 1, lambda 2. And then I just start entering. We have x1 here minus 2, there's no x2 coefficient, so 0. Then lambda 1, lambda 2 have coefficients minus 4 and minus 3, minus 4, minus 3, and lastly a constant 5 will be shifted to the right side because that's the format here, so I get minus 5 here. That's the first equation down, 3 more to go. Now here we don't have any x1 term, so its coefficient is 0. We have a minus 2 x2 term, so minus 2. Then we have minus 5 and minus 4 for lambda 1 and lambda 2. Minus 5, minus 4. Lastly, we have a 9 which we will be shifting to the other side. So we will get minus 9, not 9, because we shifted here now. But that's about it. Then for the next equation, here we don't have lambda 1 and lambda 2, so their coefficients will be 0. The other coefficients were 4 and 5. These are 0 for lambda 1 and lambda 2 and equal to 13. Lastly, we have 3 and 4. Lambda 1 lambda 2 are not there, so coefficient 0. And finally 10 goes on the other side. Minus 10 goes on the other side, becomes plus 10. So 3, 4, 0, 0 and 10. Now on solving, get x ka value as 2, means x1 ka value as 2. x1 is 2. x2 is 1. Lambda 1 is minus 17. Lambda 2 is 23. Nice, huh? So now we have no use for these lambda 1, lambda 2 values, okay? So we are only concerned with the x1, x2. Our stationary point is 2, 1. So now we need to check whether the stationary point of ours is a minima or a maxima, right? So in order to do that, firstly we have two variables and two constraints. No, whenever our number of variables is equal to number of constraints, okay, so then instead of calculating our normal del 3 del 4 stuff, we don't do that all. We instead directly calculate our Hessian matrix. Okay, our Hessian matrix is pretty simple. Okay, is basically just the derivative of a function that x1 x2 wala with respect to x1 x2. Wait, I'll show you. So it has only 4 terms: del square f by x1 square, del square f by x2 square, then we have del square f by first x2 then x1, and this one is reversed: first x1 then x2. Oh wait, sorry, I messed up. No, it was correct only. Never mind. Yeah. First x2 then x1, and over here first x1 then x2. Correct only. Yeah. So now we just look at a function for that. Where's our function? This is our function. Okay. So now del square f by del x1 square basically is, this will become 0, this will become 0, this will become 0. We'll be left with minus 2 if we do this. Similarly, if we calculate this term x2 square, we'll see that this will become 0, 0, this will also become 0, and this one will give us a minus 2 again. And now if we differentiated once with respect to x, and means x1, and then with respect to x2, we would also get a 0. You can calculate and see later if you like. And if we do the vice versa also, we would get a 0. Okay, our diagonal elements are negative, minus 2, minus 2, while the rest are 0 as we just calculated. Now in the Hessian matrix we basically need to find all the principal minors. Okay, principal minors basically means like 1 cross 1, 2 cross 2, 3 cross 3. Where's it? Like basically the entire matrix rows and columns, kind of. I'll show you. So 1 cross 1 means D1, 2 cross 2 means D2, 3 cross 3 means D3, and so on. Okay, but if you look, we only have a 2 cross 2 matrix, so we are not concerned with these. Over here we are only concerned with these two. Okay, So d1 would basically mean this term up here, and d2 would be the determinant of these all four terms, like the entire 2 cross 2 matrix. So our d1 is basically determinant of this thing -2, which is basically just -2 itself. Okay, and then d2 would be determinant of -2 0 0 -2, which if you solve you'll get +4. Now if you have what do you say, like over here we have alternating signs. No, first is negative, d1 ka sign is negative, d2 ka sign is positive. If you add more, then it will continue alternating, negative positive negative positive. But since we only have two, negative positive, so we could only see two of them, since we only have two basically. So basically sign is alternating. No, whenever the sign alternates like this, that means our stationary point is a point of maxima. So therefore a point that was, I believe, 2, 1 is a point of maxima. However, if all the points had the same sign, that is, all were positive, 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 okay, we got both of these as positive, for example, then this would be a point of minima. That's all you need to remember. This is for whenever the number of variables is equal to number of constraints, okay. So now we know that this is a point of maxima, so we can just go ahead and substitute that into a function, no? And we'll get a maximum value. Now our function is this one, no? So just calculating meet. We get the value as 14. You can solve and check if you like. So this is the maximum value of a function meep.